So next topic is gray to binary conversion and binary to gray conversion. Here we need to understand what are gray codes and why are we using them. So let us take the example of 3-bit binary code B0, B1, B2, and this B0 is LSB as you can see here, and B2 is MSB. So you can write from 0 to 7 by using these 3 bits. You can write from 0 to 7. So this is basically 0, 000 is 0, then 001 is 1, 010 is 2, and so on up to 7 we have written. Okay. Now if you want, if you see here, if you just see the 000 is here. Okay. If you go from 0 to 1, if you go from this 000 to 1, so a bit change is here. Only change in B0. No change in B1 and B2 when we go from 0 to 1. Okay, this is, if you see, this is decimal, this is decimal 0. Here I need to write here decimal 0, this is decimal 1, this is decimal 2, decimal 3, this is decimal 4, decimal 5, 6 and 7. And if you go from this 1 to 2 here, if you go from this, a change is here. Okay, another change is here because bit is going from 1 to 0 here and 0 to 1 here. So two changes, change in B0 and change in B1. So this is a, you cannot say drawback, this is the limitation of these binary numbers. More than one change can happen. Okay, if you go from this number to that number here, you can see here, if you are moving from 3 to 4, see here, if you are moving 3 to 4, all 3 bits change. This change is here, another change is here, another change is here. Okay, all 3, if you are moving from 3 to 4, 3, you can write 3 like this. This is 3, 0 1 1. How would you write 4? 4 you write like this, 1 0 0. This is 4. So all 3 bits change. This change 1 to 0, this change 1 to 0, this change 0 to 1. Okay, so many a time it is not required. We have a gray codes. Now gray codes are specially designed codes. We don't have a weight here, and now what is weight? Weight is like this. If this bit is having weight 1, this is having weight, okay, I'm not able to write on this, so you can write like this. You see that if 0 0 1 is there, so this bit is having weight 1, 2 raised power 0, this is having weight 2, this is having weight 4. Okay, this is having weight 2 raised power 0, this is having weight 2 raised power 1, this is having weight 2 raised power 2. But these gray codes are unweighted codes. Okay, so you can write like this. For 0 0 0 you will 0 0 0. Now you can see, you can take any code. Okay, you are just let us say write number corresponding to 7. 7 is 1 0 0 in Greek codes. You can see here. What is 6? 6 is 1 0 1. Okay, only one change is there. Okay, in two consecutive numbers, only one place change at one place. Okay, so this is the quality of these gray codes. Now, how would you convert this binary to gray? Let us choose any. Let us choose any one of them. I'm taking a binary like this. Binary is 1 1 1. Okay, so B0 is 1, B1 is also 1, and B2 is also 1. So we are writing corresponding to 7, binary 7. So we want to convert into gray. Just remember this figure. So B2 will be equal to Z2. So that will be equal to Z2. B2 is equal to Z2. So that will be equal to Z2. So how would you get Z1? Z1 would be equal to B2, difference between B2 and B1. So what is B2? B2 is 1. What is B1? That is 1. 1 minus 1 is 0. Okay. So Z2 is 1. Z1 is 0. Again, you also need Z0. What is Z0 now? How will you write Z1? Z1 is the difference between B1 and B0. What is B1? 1. What is B0? 1. Again 0. So that would be equal to 1, 0, 0. So you can see here 1, 0, 0. Let us solve another. Okay, we are just giving it for the 3-bit number, binary numbers. You can just extend it for any bit number. Okay, you could just add another bit here, B3 and B4 also. Process will be same. Okay. Now let us say we assume that the number is 100. So binary number is 100. So again G2 is equal to B2. So that would be equal to 1. Simple. And this, what would be Z1? Z1 will be equal to B2. B2 is 1 minus B1. That would be equal to 1. Simple. And G0, what is G0? G0 is B1 minus B0. So 0 minus 0, that would be equal to 0. So 110. So you can see here corresponding to this 110, we have 11. 100 corresponding to 100, you are getting this gray code 110. So this is how we can convert binary to gray. Binary to gray. We have converted to binary to gray. Okay, let us see how we can convert gray to binary. This is again, you have to remember these figures. Just remember this. Remember this. Okay. On the basis of this, you can solve it easily. Now, again, if you want to convert this gray to binary, we need to understand that. Now, let us take example of this. You want to convert 6 corresponding to this. You want to convert this 1, 0, 1. 101 into binary. So this is Z0, this is Z1, this is Z2. Now B2 is equal to Z2. You can see here in this, B2 is equal to Z2. So this is 1, this is 0, this is 1. Okay. So you got a 1 here. Okay. This is 1. So 1 minus 0. Okay. 1 minus 0, you will get 1 here. You see 1 here. And this G1 will, the result will go here. Result is 1. Result is 1. What is Z0? Z0 is also 1. So 1 minus 1 is 0. So what you got? You got 1, 1, 0. This is binary number. Okay, let us solve it for another number. Change the color. Now let us say that these are the number is this is 1, this is 1, this is 1. All are 1. Okay. Now you will get a 1 here because G1 will directly go to B2. Now this 1 will come here. and 1 minus 1 is, because z1 is 1, this 1 is here, 1 minus 1 is 0. This 0 will go here. Okay, definitely this 0 will go here, and this z naught is 1. So 0 minus 1 is 1. 0 minus 1 is 1. So for this 111 gray code, 111 gray code, what you got? 101. Okay, 0 minus 1 is 1, and borrow will be 1. Okay, this is the rule. You can see the previous video for this addition and subtraction rule. Okay, so this is how we can see that we can have the gray to